Introduction to tsunamis. Tsunamis are large, powerful waves caused by sudden disturbances in or near bodies of water. Unlike regular ocean waves, which are generated by wind, tsunamis result from geological events such as underwater earthquakes, volcanic eruptions, or landslides. Understanding the causes and impacts of tsunamis is crucial for mitigating their effects on coastal areas. Causes of tsunamis. The most common cause of tsunamis is underwater earthquakes. When tectonic plates shift abruptly along fault lines, the seabed can be displacing a large volume of water and generating a tsunami. Volcanic eruptions, particularly those involving the collapse of a volcano or explosive activity, can also trigger tsunamis. Additionally, landslides, whether underwater or from land into the ocean, can create waves that develop into tsunamis. Formation and propagation. Tsunamis typically start with a sudden displacement of water. This displacement creates a series of waves that travel outward in all directions. In deep water, tsunamis are not very tall, often only a meter or so high, and can travel at speeds exceeding 500 km per hour, 310 miles per hour. As these waves approach shallow coastal waters, their speed decreases and their height increases significantly, resulting in towering waves that can cause massive destruction. Impact on coastal areas. When tsunamis reach coastal areas, they can cause severe damage due to their height, speed, and the volume of water they carry. The initial wave is often followed by a series of waves that can be even larger and more destructive. The impact on coastal areas includes flooding, erosion, and the destruction of infrastructure, such as buildings, roads, and bridges. Tsunamis can also lead to loss of life and long-term environmental damage. Flooding and erosion. The force of a tsunami can cause extensive flooding, inundating low-lying coastal areas and causing significant property damage. The powerful waves can also erode coastlines, altering natural landscapes and ecosystems. Beaches and coastal vegetation can be washed away, affecting local wildlife and habitats. Tsunami warning systems. To mitigate the impact of tsunamis, many regions have developed tsunami warning systems. These systems use seismic sensors to detect underwater earthquakes and ocean buoys to monitor changes in sea level. When a potential tsunami is detected, warnings are issued to coastal communities, allowing for evacuation and preparation. Early warning systems and public education play a crucial role in reducing the loss of life and damage. Historical tsunamis and their impact. Historical tsunamis, such as the 2004 Indian Ocean tsunami and the 2011 Tohoku tsunami in Japan, illustrate the devastating impact of these events. Both tsunamis caused widespread destruction, with significant loss of life and long-term economic and environmental consequences. These events highlight the importance of preparedness and response in minimizing the impact of tsunamis. Mitigation and preparedness. Communities in tsunami-prone areas are encouraged to develop and implement preparedness plans, including evacuation routes, emergency shelters, and public education on tsunami risks. Coastal development regulations and infrastructure improvements can also help reduce vulnerability to tsunamis. Building resilient communities involves understanding the risks and taking proactive measures to protect lives and property. Conclusion. Tsunamis are powerful natural phenomena caused by sudden geological disturbances, such as underwater earthquakes, volcanic eruptions, or landslides. Their impact on coastal areas can be devastating, leading to flooding, erosion, and extensive damage to infrastructure. Effective tsunami warning systems, preparedness, and mitigation strategies are essential for reducing the impact of these catastrophic events and protecting coastal communities.